Hello, in this video I'm going to talk about Analog Discovery 2 and how you can use the software to work with the Analog Discovery 2. So first you need to go to analogdiscovery.com and go to the download section and download the required software based on the operation system you have. Then you do the installation. Installation is not that hard. I have done that and I have the waveform software on my personal computer. Then as you can see, because the Analog Discovery is not connected to my personal computer, I get this error. So you just need to connect the USB cable to your computer. Let's retry, and you can see that there are different panels here, and these tools are used during the experiments, to do the experiments. By clicking once on them you can open them, and you can switch between different for example, you have a scope here, oscilloscope here, and you can have the waveform generator and supplies and the voltmeter. These are frequently used. These four are frequently used to do the electronic experiments. The scope is used to see the waveforms in different parts of the circuit. The waveform generator is used to produce input signals with different specifications. Supplies are used for the DC supplies, and voltmeter used to measure the DC values. This play button means that you need to click on them to work, and this red circle means that you can stop them. Hello everyone, this video is about lab number 1, getting started, instrumentations and measurements. So the first thing that you need to do is to connect the Analog Discovery 2 to your personal computer and open the waveform software. Then I need you to know that these few wires here are not going to be used for this experiment. As you can see here, the input and output terminals of the Analog Discovery 2 has been labeled. The first two one are the orange one and the orange one with a white strip are used to work with the oscilloscope, which means when you want to see an output waveform on this software. Okay. The second one is the second channel of the oscilloscope, the blue one and the blue one with the white strip. The third one is the ground, and the fourth one, which means this brown one, and this is reddish brown, something like this. It's red almost. The red one and this white one are used to have DC values for your power supply. And then you have the yellow one, which and the yellow one with the white strip on it, which are used for the waveform generator, which means when you want to inject signals in your to your circuit. Again, after that you have the ground, and after that you won't use these input and outputs. So as you can see here, again, these two are used for the oscilloscope. The orange ones, the blue ones are used for the second channel of the oscilloscope. After that you have the ground, okay, these black ones, and then you have the yellow ones, which are for the waveform generator. And you should understand that you can use one of these only one of these waveform generators and the ground. I will discuss this later. So the first experiment asks you to do a few things. As you can see here, for the procedure, it says that use the function generator to generate a sinusoidal waveform with amplitude 5 volt and frequency 1000 hertz, which is 1K, and then verify the waveform with the multimeter and oscilloscope. So let's move to the circuit. We need to provide a sine wave that has amplitude of 5 volt and frequency of 1K. So the first thing that you need to do, as we mentioned before, is to provide a signal using the waveform software. So first you go to wave generator tool, then you specify the type of the signal that you want. For example, either it's sine wave, a square wave, or whatever, and then you choose the frequency. For example, in this case it's 1 kilohertz, and then you choose the amplitude. The maximum amplitude is 5 volt here. So your peak voltage is going to be 5 volts, and the peak to peak is going to be 10 volts. Now that our signal has the specification that we want, by pressing the run, you are allowing the software to inject this signal to the analog discovery kit. So now this because this is and you need to know that this is a wave gen 1, which means that according to this paper, wave generator 1 is the yellow wire without a strip, white strip on it. The other one is wave gen 2, okay, and we are using wave gen 1, okay. So now the signal is going inside this wire, the yellow one. I will put it somewhere on my breadboard. Okay, let's get rid of the other wires. So this one is connected to the wave generator 1 wire, which is the yellow one, and then I need a ground for this, because you need a reference voltage, a reference ground for this signal. So I will choose one of the black wires here. As you can see here, either the second on the top or the sixth one on the top is ground. So I will choose the second one, and you just need to push the wire inside this one, and this will fix, and then you can use the other one as the main wire. So as we said, the yellow one is going to be the signal, and this black one is going to be ground somewhere on our breadboard. And you know that these lines are connected together. These lines on the breadboard are connected together, but they are separated by this. So these are not connected to these ones, okay? And they are not connected in this way. So only in this way they are connected together. One line here, all the pins are connected together. So now we have the signal on the breadboard. If we want to see the signal, we need to connect because we want to verify it, we need to connect the oscilloscope. Either we want to use the multimeter, or we want to use the oscilloscope. We need to use the oscilloscope cable, which has been labeled here. You see channel 1 and the positive of the oscilloscope channel 1 and the negative of the channel 1. So I choose the first channel, and the positive is going to be the yellow one without a strip. I'm going to connect it here to the positive, and I'm going to connect the negative, which is the negative of the oscilloscope channel 1, which is the orange one with the white strip on it, to this row here. Okay, so as I said, this line, the pins in this line are connected together, and the pins in this line is connected together. Now we need to move to the waveform software once again. You go to the welcome page, you choose the oscilloscope, okay, and you just need to press the run, okay. And so you see that it's showing two things. One of them is channel 1, which we are using, and another one is channel 2, which we are not using, so it's getting some noise on it. How you need to fit this signal into the oscilloscope, okay? So what you need to do is go to the channel 1 and change the range per the vertical scaling. So for example, I make it 1, it gets more compressed in the vertical axis. I make it 2, more compressed, okay. And you have the time domain here too. This is for time domain. You can make it wider or more compressed, as you can see, okay. And I'm going to make it wider.
Now let's say that we want to do some measurements. First, you need to press on the single button here. Then you press the measurements. Then you press add. Then you press define measurement. You choose the channel. Then you choose either it's a vertical specification or a horizontal specification. For example, here I choose V peak to peak. I press add. Another value, for example ACE. I press add. Then horizontal frequency, add, and I press close at the end. Here you can see the measured values: pole voltage, AC RMS, and frequency. In the next step, you have been asked to do the measurements using multimeter. So you go to compare, then you click on voltmeter, and then you play run. You can see that you're getting the same ACRMS here, but this is different from the peak-to-peak voltage. And as the manual asks you, you need to answer the question about this difference, that different values that you see. The next part of the question asks to use the function generator to generate a square wave with maximum of positive 5 volt and minimum of negative 5 volt. And the frequency needs to be 1 kilohertz and the duty cycle is 20%. So we go to workspace, and I've done this thing before. I'm going to close this. So we go to the wave generator. You choose the type of the signal to be a square wave. The frequency needs to be 1 kilohertz and the amplitude needs to be 5 volts, as you can see. The duty cycle needs to be 20%, and then you press run. Then again you go back to the welcome page. You press on the oscilloscope and you press the run and you press single. Then like adding the peak to peak voltage, I have added the positive duty cycle here. This is how you do it. You go to measurement, channel 1, horizontal, and positive duty cycle. So these are the measurements that you need, and you see that the measurements are correct.
The next part of the question, meaning 3.3, is asking you to construct a circuit given in figure 2 and then calculate the voltage across resistor R3. So what you need to do is to pick 300 ohm resistors, as you can see in figure 2. Then you build the circuit this way. So let's put this resistor here, and then the 2 other resistors. Let's make this straight, okay? And then you put this resistor somewhere here. So it means that these 2 resistors are connected, as you can see in the figure 2.2. And then you bring it somewhere here, let's say, and then you have the next resistor. It goes in parallel with this resistor. You put it somewhere here. So it needs to be again in the same row here. It needs to be in the same row. And this one again here. It's in the same row with this pin of the previous one. And then you need to connect the ground. I'm going to use this ground. It doesn't matter which ground you're using. I'm going to connect the ground here. And then you need to connect the 5 volt DC, as the question part B is asking you to connect the 5 volt DC. So which pin is the 5 volt DC? Let's take a look at this paper. So this one will give you the power supply, the red one, the fourth from the top. So we go here. This one will provide the DC voltage. I have connected the connector wires before, so you need to do that. I'm going to put it again in the same row. Okay, so now I have the circuit all done. And the question is asking you to measure the voltage of R3 with oscilloscope and see the maximum and minimum voltage. R3 is this one. To do the measurement, you also need to connect the oscilloscope wires to your circuit. These are from the previous part. I'm bringing them out, and so the oscilloscope, as you can see here, the positive is the orange one here. Okay, the positive goes to this node that I want to measure the voltage of it, and the negative is this one, which goes here. So I'm measuring the voltage across this R3 resistor. Okay, they are all, as I said, connected in this node, and these are all connected in this node. Now let's move to the waveform software and see the output.
The next part of the question is asking you to, 3.3 part B is asking you to add the 5 volt voltage, DC voltage as input, and then see the voltage across resistor R3. And you need to use the oscilloscope for that. I'm going to move to the waveform software. Here, using supplies, you can give the input voltage, the power supply. So I'm going to give 5 volts as input, and then I need the oscilloscope to see the output, and I run the oscilloscope. Now I haven't run the supplies yet, so I run the supply, and you can see that the output is changed from 0 to some value here. To see the value, you can use the cursor. First press on single so that you can have only one fixed image, and then press on this option here. It will allow you to see the voltage across different times through the time. So you can see that it's 1.6 something, that is in accordance with the calculations. The next part of the question, 3.3 part C, is asking you to replace the 5 volt DC with a 5 volt 60 Hz sinusoidal, and then measure the voltage across the R3 resistor. So as you can see, I will go to the wave generator. I will choose the sine wave. I will choose the frequency to be 60 Hz, and the amplitude is 5 Hz. So this is my input. By the way, at the same time, I have changed all the resistors in my circuit from 100 to 1 kilo ohm resistors, and then I'm going to open the oscilloscope, and this is the result that I'm seeing. Okay, and you can see that the maximum is 1.6 something, which is in accordance with what we expected. To do the measurements, again, you need to open the measurement panel and add the measurements that you need here.